Hello, welcome to this short introduction to hypothesis testing. First, we are going to explore some basic terms related to hypothesis testing. Hypothesis testing is a statistical procedure in which a choice is made between null and alternative hypotheses based on the information in the sample. Meaning of that is, by looking at the sample, we are going to formulate hypotheses. One is called the null hypothesis, and the other one is called the alternative hypothesis. And using the statistical test, we are going to make a choice between the null or the alternate hypothesis, which hypothesis to accept and which hypothesis not to accept. But what actually is hypothesis? Hypothesis is conjecture about the population parameter. So by performing the hypothesis testing, we are making some conjecture about the population parameter. And for that, we write a statement called hypothesis. And from here, we have clearly seen that the hypotheses are of two types, the null hypothesis and alternative hypothesis. Now, what are null and alternative hypotheses? Null hypothesis, denoted as H sub 0, is the statement about the population parameter that is assumed to be true unless there is convincing evidence to the contrary. Meaning of that is, when we write the null hypothesis about the population parameter, it is considered as the true statement about the population parameter. This will be true if we don't have any convincing evidence to support its opposite hypothesis or the alternative hypothesis. So what is an alternative hypothesis? The alternative hypothesis, which is denoted as H sub A or H sub 1, is a statement about the population parameter that is contrary or contradictory or opposite to the null hypothesis. And this hypothesis, that is the alternative hypothesis, is accepted as true only if there is a convincing evidence in favor of this. Okay, after we know what are null and alternative hypotheses, we want to look at the procedure for writing the null and the alternative hypothesis. The first thing is the entire test, the hypothesis testing, is a test procedure which is based on the initial assumption that the null hypothesis is true. We consider the null hypothesis to be true and we perform the test to see whether it is actually true or not. And null hypothesis contains equality sign all the time. Like here you can see in this one, H sub 0, that is the null hypothesis, mu equal to constant. In the second case, mu equal to constant. In the third case, mu equal to constant. So here, the parameter that we are testing is the population mean mu. In all these, you can see for the null hypothesis, okay, for the null hypothesis, there is equal to sign. So parameter equal to some value. So whenever you are writing null hypothesis, make sure you have equal to sign in it. Now, null and the alternate hypothesis are opposite of each other. Meaning of that is, what you'll see is that there are so many instances where you'll see the alternative hypothesis may contain opposite relation to the null hypothesis. The first alternative hypothesis that I have here is mu is not equal to k. Null hypothesis mu equal to k, alternative hypothesis mu not equal to k. You may have mu greater than k. You may have mu less than k. Mu is the population mean that we are testing here. So you can see that in the alternative hypothesis, your parameter may contain not equal to sign, greater than sign, or less than sign. Now, based on this, we say that our tail may be two tail test, right tail test, or left tail test. How? Let me show you here. I have three normal curves here for each case. In case of two tail test, when we say not equal to, this is a two tail test. Meaning of that is your rejection region will be at the end of the tail. at both tell, you'll have the rejection reason. This is the rejection reason. Let me write here, rejection reason. Okay, this reason is the rejection reason. Now here in the second case, you have mean greater than k. So when you have greater than, this is the right tail test. Meaning of that is your tail is right here. Okay, this is the rejection reason. Rejection reason is that one. And if the alternative hypothesis contain the parameter is less than some value, it is a left tail test. So your rejection reason will be here. This is the rejection reason. Okay, so the reason in the middle now, this reason here, this is the acceptance reason. Acceptance reason. Okay, this is the acceptance reason. This is the acceptance reason. Now this area on the tail, in two-tail test, this area plus this area, the total area is called the p-value. This is called the p-value. This one is also the p-value. We have area on just on one side, that is p-value. This area over here on the left tail, that is the p-value. Why we need to know about p-value? Because in hypothesis testing, there are two methods to perform the hypothesis testing. One is called the traditional method, and the other one is called the p-value method. What I'll be using in my upcoming lecture is I'll be using p-value method to perform the hypothesis testing. So always remember, p-value is the area on the tail. For the two-tail test, it is the sum of area on the two tails. For the right tail test, it is the area at the end of that right tail. And for the left tail test, it is the area on the left tail. Okay, that is about the p-value and how we write the null and the alternate hypothesis. Always remember, null hypothesis always have equal to sign. A population parameter is equal to something. Whereas the alternative hypothesis does not contain equal to sign. Meaning of that is, in alternative hypothesis, you may have not equal to sign, greater than, or less than sign. Next, errors in hypothesis testing. After we perform the hypothesis testing, there are chances that we'll make a wrong decision. The wrong decision that we make in hypothesis testing, that is called the error in hypothesis testing. And basically there are two types of error. The first one is called the type 1 error. Meaning of that is, if you reject the null hypothesis, okay, if you reject the null hypothesis, when it is actually true, it is called type 1 error. So you reject the null hypothesis, it was actually true, then the error you made is the type 1 error. The second error is type 2 error. That is, if you do not reject the null hypothesis when it is false, you are not rejecting the null hypothesis, but it was actually false. Okay, in that case, the error you made is the type 2 error. In two other cases, that is, you reject the null hypothesis and hypothesis is false, you make a correct decision. It is called true positive. You fail to reject the null hypothesis and the null hypothesis is true. In that case, you make a correct decision again. It's called the true negative decision. So there are two types of error. Always remember, type 1 error and type 2 error. In type 1 error, you reject the null hypothesis when it is true. And in type 2 error will occur when you do not reject the null hypothesis when it was actually false. Now, the last thing that we want to go over in this introductory video is what is p-value method for hypothesis testing? How do we do this? So what we do is, by reading the problem, first we identify the claim. What is the claim? And we state the null and the alternative hypothesis. So first, we have to figure out, or we have to state the null and the alternative hypothesis. Null hypothesis must have an equal to sign. Alternative hypothesis may have not equal to, greater than, or less than sign. And out of these two, null and alternative hypothesis, you also need to figure out what is the claim, which one the researcher is claiming to be true. Then after that, you have to calculate the specific test statistic using the data or statistics given in the problem. So using the given data or using the given statistic, you have to find something called the test statistic, because we are going to compare, or we are going to use this to calculate the p-value. So in second step, after we have the null and the alternate hypothesis, you have to find the test value. Then using that test value, in third step, you have to find the p-value. Okay, and from the previous slide, you already know that generally the p-value is the area in the rejection region or in the tail region. For two tail test, it is the sum of area on the two tails. For the left tail test, it is the area on the left tail. For the right tail test, it is the area on the right tail. So that is the third step. Now, once you have the p-value, now what you're going to do is you're going to compare your p-value with the significance label. When I say significance label, it is the opposite, I can say, or opposite of the confidence label. For example, if we are talking about 95% confidence label, then the significance label will be 100 minus 95, that will be 5. So alpha is the significance label, which will be given in the problem. So we need to compare our calculated p-value, that is the area on the tail, with the significance label that is given to you. Significance label will be given to you in each problem. How we are going to compare? If the p-value is less than or equal to the significance label, then we reject the null hypothesis. But if the p-value is more than the significance label, in that case, we fail to reject the null hypothesis. That means in this case, when you reject the null hypothesis, you support the alternative hypothesis. When you fail to reject the null hypothesis, meaning of that is you are supporting this hypothesis. So once you perform all these 4 steps, on the final step, you are going to state the result for your hypothesis test. So in the upcoming videos, we are going to look at the examples on how we are going to use this p-value method to perform hypothesis testing. But for this introductory video, I'm going to stop here. Thank you so much for watching. I hope you find this useful.